At 4:17 a.m., the universe does something it almost never does. It stops being noisy. A spike rises from the static, thin as a needle, steady as a vow, and for a few seconds you can feel an ancient human fear return. What if we're not alone? And what if we don't recognize the hello? January 2026. You're here with me, fluorescent lights, stale coffee, and that peculiar winter silence that makes every keyboard tap sound too loud. Frost clings to the control room window like the building is trying to keep the cosmos out. Someone has opened a brand new notebook to page 1. Across the top, in careful block letters, Contact Protocols version 1.0. That's not superstition. That's a confession. We don't actually know what we're doing. For hours, the sky has been its usual self, a river of interference, a quilt of natural sources, human technology bleeding into the night, the patient hiss of the Milky Way. There's always a temptation in rooms like this to turn awe into routine. You start calling miracles data. You start believing the next shift will be like the last. And then, for 17 a.m., the narrowband spike appears. It's too stable, too clean, too deliberate. And the entire room changes temperature without any thermostat moving. Not colder, sharper. Like the air has decided to pay attention. A narrowband signal, in simple terms, is a voice that refuses to spread out. Nature usually sings in chords and choirs, messy, wide, textured. A narrowband transmission is a single flute note held perfectly in tune. It's the sort of thing engineers build when they want a receiver across unimaginable distance to notice. Nobody says the word aliens. That's not how it happens in real life. In real life, people go quiet. Someone's hand freezes over the mouse. The scrolling waterfall plot, our rainstorm of radio color, shows one impossibly straight line. The kind of straight line that makes your stomach do something you can't quite name. And right away, the first question arrives, raw, human, humiliating. If we heard a voice in the dark, how would we know it's a voice, and not the universe clearing its throat? Because misclassification cuts both ways. Declare intelligence over noise, and you become a cautionary tale. Ignore the only hello we ever get, and you become something worse, a species that slept through its own turning point. So we do what scientists do when our pulse starts writing hypotheses for us. We audit. We strip the romance off the signal and ask, what is the minimum evidence required to call something intelligent? Is meaning something transmitted, or something the receiver constructs? And if the thing out there doesn't share our senses, our bodies, our culture, what could a handshake even be? I want you to feel the tension of this moment, because it's not just about aliens. It's about you, and me, and the way a human brain hunts for patterns even when none exist. The oldest stories of our species start with shadows in the trees and a question, friend or predator? Today the forest is interstellar, and the shadow is a single line on a screen. We begin with the first audit, rule out nature and humans. Somewhere, a graduate student is already pulling up catalogs, known pulsars, known masers, known quirky objects that make narrowish signals. Because nature can absolutely produce patterns. Pulsars, rotating neutron stars, are so regular they were briefly nicknamed LGM4. Little green men, in the 1960s before the physics became clear. It's funny now, but in the moment it wasn't comedy. It was humility. Here's the fingerprint idea. Every phenomenon has a style. Nature doesn't just make a signal, it makes a signal with baggage. Doppler drift, for example. If the source is on a rotating planet, orbiting a star, inside a galaxy, the frequency will slide, like a siren passing you on the street, but stretched across the celestial scale. Harmonics. Nature often produces families of frequencies, not a single lonely line. Astrophysical context. A signal that aligns with a known star-forming region or a pulsar's coordinates comes with a plausible biography. And humans make patterns too. Satellites, radar, leaked carriers, digital transmissions reflecting off debris. We've wrapped Earth in a shimmering cocoon of radio. Sometimes, looking for aliens is like listening for a whisper while standing inside a nightclub you built yourself. So the checklist begins, and it's oddly intimate, like searching for a hidden microphone in your own home. We measure Doppler drift. We check the bandwidth. We look for repetition. We verify the sky position. We cross-reference known transmitters. We call people who are half awake and ask if they have hardware pointed anywhere near that frequency. The signal survives the first round. That doesn't mean it's extraterrestrial. It means it's stubborn. It refuses to die under the simplest explanations. And that's when your mind starts doing something dangerous. It starts narrating. You can feel it, right? The urge to jump from unusual to meaningful. That jump is where most of humanity's biggest mistakes are born, and also some of our greatest discoveries. So we slow ourselves down. Extraordinary claims don't require just improbable data, they require multiple independent lines of consistency. The universe can fake one clue. It struggles to fake 5 that all agree. Now the room turns to a comforting idea, one that's been with SETI, the search for extraterrestrial intelligence, for decades, math as a universal language. On the whiteboard, someone sketches a sequence of prime numbers. 2, 3, 5, 7, 11, it's the scientific equivalent of waving your arms in the dark and saying, "If you can count, we can meet here." Primes feel like bedrock because they don't depend on English or eyes or fingers. They're properties of quantity itself. Simple ratios, spectral lines, geometric relationships, these seem like the closest thing we have to culture-free statements. There's a reason the famous Arecibo message in 1974 used binary and tried to climb a ladder from counting to geometry to chemistry to location. It wasn't poetry, it was an attempt at scaffolding. But even as the primes go up on the board, I feel a quiet discomfort. And maybe you do too. Because that comfort is a kind of assumption. Comforting to whom? Here's the subtle trap. We're assuming the receiver segments reality the way we do. That it thinks in discrete symbols. That it treats numbers as objects you can pass back and forth like stones. That it sees patterns as something you write down, rather than something you inhabit. What if their cognition is continuous, more like fluid dynamics than arithmetic? What if they don't think in things, but in transformations? What if what we call a number is, for them, as arbitrary as our constellations, patterns imposed on a sky that doesn't care? So the primes are comforting. But comfort is not evidence. Comfort is a sedative. To keep ourselves honest, we ask a harder question: what does intelligence look like in our world? Not complexity. Snowflakes are complex. Hurricanes are complex. The coastline of Norway is complex. Complexity can be an accident of physics, beauty without intention. Not novelty. Randomness is endlessly novel. A radio tune between stations produces a story that never repeats. But it isn't telling you anything. It's the universe rolling dice in your ear. So what are we actually looking for? A better signature is something I'll call adaptive modeling. Let me translate that into a metaphor before we get technical. Imagine a creature walking through fog. It can't see far, so it builds a map inside itself. Each step updates the map. The map predicts what the next step will feel like. And then, here's the key, the creature uses the map to choose a better next step. That loop, model, predict, intervene, is the heartbeat of intelligence as we know it. It's not just reacting. It's anticipating. It's compressing the world into a usable theory. In information terms, intelligence often reveals itself as compressibility of a special kind. Not the cheap compressibility of repetition, like AIA, and not the false compressibility of us forcing a story onto noise. The powerful kind, where a pattern is simple once you've discovered the right rule, and that rule lets you predict new data. We watch the data scroll, and we realize we're not hunting for weird. We're hunting for compressible in a powerful way. Now stay with me, because this is where the problem becomes almost philosophical, and almost painfully personal. Suppose the signal is artificial. Suppose it's engineered. Even then, we're not done. Because artificial doesn't equal intelligent. A beacon can be dumb. A relic can be blind. A dead civilization can leave a voicemail that plays forever without anyone listening on the other end. So the question sharpens. How do you recognize a non-human mind without shared priors? Priors is a word from statistics and cognitive science. It means the assumptions you bring before you see the evidence, your default expectations, your built-in guesses. If you and I both grew up seeing trees and faces and hearing speech, we share priors about what counts as a message. But if the sender evolved under different physics, different senses, different everything, then our priors may be a trap. This is the alien handshake problem. And it's not a gimmick. It is the core difficulty of first contact. Not, can we detect them? But, can we recognize them? The first paradox is what I call the shared reference problem. To communicate, we need joint attention. That's a fancy way of saying, we need to know what we're both pointing at. Two humans can point to the moon. A parent can point to a dog and the child learns the word. It's not the sound that teaches meaning, it's the shared act of reference. But what if an intelligence has no vision? No sound? No bodies in any sense we understand? What is pointing then? Picture yourself trying to explain red to a creature that has never had eyes. You can't. Not directly. You can only route around the missing sense by pointing to something deeper, like wavelength, energy, frequency, if those concepts exist for them. So in the control room, we start looking for things that are invariant, anchors in physics that don't care about biology. The hydrogen line at 1420 MHz, radio emission tied to the most common element in the universe. Pulsar timing, cosmic lighthouses with predictable rhythms. Fundamental ratios. Symmetries. Conservation laws. Causal structure. Because if you can't point to culture, you point to reality's skeleton. But even here, there's a second trap waiting, the translation trap. Humans are pattern-finding machines. We see animals in clouds, faces in outlets, omens in coincidences. That's not stupidity, that's survival. The cost of a false positive, thinking the bush was a predator, was small. The cost of a false negative, ignoring the predator, was death. Evolution tuned us to hallucinate meaning on the safe side. So if a strange signal arrives, our brains will happily translate it into whatever story we most want, or fear to hear. The danger is not just that we might miss a message. The danger is that we might invent one. How do we avoid that? We demand a message that does something only a mind would do, generate new, correct predictions about the world that we did not encode ourselves. That's the difference between a horoscope and a physics equation. A horoscope can feel meaningful, but it doesn't reliably let you predict an eclipse. A real model reaches into the future and pulls something back. So we begin to imagine a test. Could the sender encode information that allows us to anticipate an observation, say, a spectral line shift, or an astronomical event, or a property of a nearby object that we haven't measured yet? If the message makes risky predictions and those predictions come true, we're no longer just interpreting. We're collaborating with an external intelligence. Now we hit the third paradox, the non-human prior problem. Even math might be ours in presentation. Base 10 because of fingers. Discrete symbols because of writing. Euclidean intuition because our world is locally flat at human scales. But their cognition might be topological, thinking in holes and knots rather than angles. Or dynamical, thinking in flows and attractors. Or something we don't have a word for yet. So how do you build a bridge without assuming the shape of the other shore? You use multiple encodings of the same content and look for what survives transformation. Like recognizing a melody across instruments. The violin and the piano don't share timbre, but the relationship between notes persists. In practice, this means, if we think the sender is communicating a structure, we should see that structure expressed redundantly, through timing and frequency, through repetition and modulation, so that no single encoding choice is the entire story. And then we arrive at the deepest question, the one that turns the control room into a kind of courtroom for reality itself, the credible mind signature. What is the minimum handshake that says, I am an agent, not a phenomenon? A single message could be anything. A beacon. A relic. A cosmic prank. A natural oddity we haven't catalogued. A dead civilization's last broadcast, looping like a lighthouse whose keepers are gone. So we need something interactive. A challenge response. An exchange that changes when we speak back. Adaptive error correction that reveals an expectation of dialogue. A gradually deepening protocol that demonstrates model building. This is where you can feel the room splitting into two instincts. One instinct is childlike, send primes back. Wave. Show we're here. The other instinct is almost parental, don't touch the stove yet. Don't broadcast your assumptions into the dark and call it communication. And then, quietly, an idea lands in my mind with the weight of a drop tool. Someone suggests sending primes. I look at the whiteboard. I look at the signal. The data keeps coming in its thin, unwavering line. And it clicks. Primes are a test of arithmetic, not a test of mind. A mind is not proven by the ability to generate numbers. A mind is proven by the ability to align with another mind, by building a shared model of reality across the gap. If intelligence is the ability to compress the universe into a working theory, then the first message shouldn't be a picture. It should be a compressor. Let's unpack that, because it sounds poetic, but it's also painfully practical. Compression, in this context, isn't about zipping files. It's about discovering structure that reduces surprise. A good theory is a compressor. It takes a huge set of observations and replaces them with a small set of rules. Newton's law of gravity compressed the motion of apples and planets into one sentence. Maxwell compressed electricity, magnetism, and light into a handful of equations. So imagine a first contact handshake not as, here are our symbols, but as, here is a method, an algorithm, that will let you and us converge on the same description of reality. That would be unmistakably mind-like. Because it doesn't just shout, it teaches. It anticipates misunderstanding and routes around it. It doesn't assume shared culture, it manufactures shared reference. Now the notebook titled, Contact Protocols version 1.0 stops being a formality. It becomes our lifeline. And we start writing not a message, but a protocol. A sequence of tests that, if passed, would make intelligence not a wish, but an inference. Step 1. Establish artificiality via redundancy and error correction structure. This is the engineering smell test. Natural sources can be narrowband, but engineered signals often carry telltale scaffolding, repeated headers, synchronization patterns, parity checks, interleaving, ways to survive noise. Think of it like this: nature throws bottles into the sea. Engineers put messages in waterproof cases with instructions for how to open them. If the signal contains layered redundancy, information repeated in mathematically related ways that let you reconstruct it even when parts are missing, that's not just structure. That's intention anticipating adversity. So we look for that. Does the signal have a backbone? Does it look like it expects the universe to be messy and plans accordingly? Step 2. Establish shared physics via invariant anchors. Instead of starting with our alphabet of numbers, we start with reality's alphabet. Hydrogen line. Electron to proton mass ratio. Fine structure constant. Pulsar timing. The idea isn't that these are universal words. The idea is that they are universal meeting points. It's like agreeing to meet at the only mountain visible from both valleys. You don't have to share language to find the same peak. So a good handshake might say, in effect, we're using this spectral line as 0. We're measuring time by this pulsar. We're counting by this ratio. Not because it's beautiful, but because it reduces ambiguity. Step 3. Demonstrate intentionality via adaptive structure. This is where the story becomes alive. Does the message change in response to our reply? If we transmit something back, carefully, minimally, with humility, does the incoming signal adjust? Do they correct for our Doppler frame? Do they shift encoding when we fail to decode? Do they send clarifying redundancies? A waterfall plot can start to look like a conversation. Not because it contains words, but because it contains accommodation. Accommodation is one of the deepest signs of mind. When you speak to a child, you simplify. When you speak to a foreigner, you slow down. When you speak to an expert, you tighten your logic. The ability to model the receiver and adapt. This is social intelligence in its purest mathematical form. Step 4. Demonstrate mind via predictive power. Here's the hard standard. The sender encodes a model that helps us predict an observation we haven't made yet. Not vague. Not interpretive. Specific. For example, point your instruments at this coordinate at this time, and you will see a transit. Or, you will detect a spectral line split consistent with this magnetic field. Or even, there is a planet in your own system with this property you have overlooked. If that prediction lands, if the universe itself confirms the content, then meaning stops being something we project. It becomes something that reaches out and rearranges our expectations. At that point, you're not just receiving a message. You're receiving a lever for reality. Step 5. Only then attempt semantics, objects, diagrams, words. Only after we've aligned on anchors, proven adaptation, and validated predictive power do we try the fragile stuff, pictures, chemistry diagrams, maps, representations of bodies. Because semantics is where misunderstanding breeds. Semantics is where you can accidentally send a smile and have it received as a threat. Notice what this protocol does. It doesn't start with our ego. It starts with our shared vulnerability to being wrong. It treats first contact not as a performance, but as a calibration. And now, in the control room, the signal is still there, thin, unwavering. You can hear the building settle. Someone exhales like they've been holding their breath since 4:17. The notebook page is filling up with crossed-out assumptions and cleaner questions. Because the real implication of first contact is not that we'll learn a new language. It's that we'll be forced to audit our definition of intelligence itself. Right now, notice how easily we confuse intelligence with familiarity. We call dolphins smart because we see play. We call primates smart because we see hands. We call machines smart when they speak in sentences that resemble ours. But those are mirrors, not measures. First contact would reveal how provincial our mirrors are. Meaning might not be a substance traveling through space like a package. Meaning might be a process, an alignment between two world models. Two compressions of the same universe, trying to overlap. And that is deeply human, even if the other mind is not. Because it drags our private inner lives into the open. It forces us to ask, when you hear a sentence, what are you really hearing? Sound waves? Or the shape of another person's model of the world? The most universal language may not be math facts recited like passwords. It may be the ability to build shared invariants, shared reference points, so that two radically different minds can coordinate on what is real. And here's the part that I find both exhilarating and unsettling. A truly alien mind could be closer to a new physics than a new culture. Culture is variation within a shared human architecture. But an alien intelligence may carve reality at different joints. It may notice regularities we've missed because our senses and intuitions keep steering us toward the same familiar patterns. Imagine that. The first message is not, "We come in peace." The first message is a new way to see. And suddenly, the control room is not just a place where we listen. It's a place where we might be rewritten. Now the spike begins to fade. Not dramatically. No cinematic cut. It thins, it trembles, it slips back into the hiss, like a hand withdrawing into darkness after touching the surface of a lake. Dawn edges the horizon. The frost on the window loses its bite. The coffee tastes even worse in daylight. But the notebook, Contact Protocols version 1.0, no longer looks like a blank page waiting for science fiction. It looks like the first draft of humility. We don't end with certainty. We end with a protocol, a way to be rigorous without being arrogant, open without being gullible, ready without being reckless. So here's the synthesis, what we've actually learned tonight. A strange signal is not a story. It's a test. Nature makes patterns, and humans make patterns, and we have to exhaust those before we earn wonder. Math can be a bridge, but it can also be a comfort blanket we clutch too tightly. Intelligence is not just complexity or novelty, it's adaptive modeling, the ability to compress reality into rules that predict and intervene. And the closest thing to a universal handshake is not a symbol. It's a method for aligning world models, proven through redundancy, invariance, interaction, and predictive power. Now let me leave you with a thought experiment to carry into your own life. Imagine you wake up tomorrow with no shared language with anyone you love. You can't use words. You can't use gestures the same way. Your memories are intact, but your bridges are gone. How would you prove you're still you? You wouldn't do it by listing facts. You'd do it by anticipating them. By aligning. By showing you can model their needs and meet them where they are. That's what a mind does. That's what a handshake is. And that leads to the next great question, the one that opens a door we haven't walked through yet. If the universe ever offers a hand, will we recognize the shape of the gesture, or only the shape of our own expectations? If you want to keep going, click the video on the end screen, because it takes this same idea and pushes it until our everyday sense of reality starts to wobble. And I'm curious, what would you consider the minimum undeniable proof of a non-human mind, an interactive reply, a correct prediction, or something else? Answer in one sentence. And if you want more investigations like this, where we don't just chase mysteries, we audit them, subscribe. Not for answers. For better questions.